Hello everyone, this is Socio today. Today our topic is scientific observation. Science is based upon the verifiable evidence. By evidence, we mean factual observations other observers can see, weigh, count, and check for accuracy. Scientific observation is not the same as just looking at things. We have all been looking at things all our lives, but this does not make us scientific observers any more than a lifetime of sweating flies makes us entomologists. How does scientific observation differ from just looking at things? Scientific observation is accurate. Scientific observer tries to make sure things are exactly as described and avoids jumping to conclusions. Novelists may fantasize and politicians may exaggerate, but the scientist must try to be accurate. Scientific observation is precise. While accuracy refers to the truth or correctness of a statement, precision refers to degree or measurement. No respectable social scientist would say, "I interviewed a lot of people and most of them feel that things are terrible," and claim this was a scientific investigation. Since scientific writing is precise, scientists avoid colorful literary extravagance. Tennyson's lines, "Every moment dies a man, every moment one is born," is literature, not science. If written in scientific precision, it might read, "Every 0.596 seconds, on the average in 1980, died a person. Every 0.2448 seconds, an infant was born." Literary writing may be intentionally vague, stimulating the reader to wonder what is meant, but the dramatic sweep of the novelist and the provocative imagery of the poet have no place in scientific writing. How much precision is needed? A billionth of an inch is too large an error for a nuclear physicist. For a social scientist studying crowded housing, a measure to the nearest square foot is satisfactory. Scientists seek as much precision as the situation requires. If conditions of observation do not permit such precision, the scientist must qualify judgment until more precise observations can be collected. Scientific observation is systematic. Conclusions based on casual recollections are unreliable. Judgments which begin with "I've talked to a lot of people" and should be classed as conversation, not as research. Unless observations have been collected in an organized, systematic program, they are likely to be spotty and incomplete. Scientific observation is recorded. Human memory is notoriously fallible. Suppose a professor says, "Women usually do not do as well in this course as men." Unless the professor has computed average score for men and women students, he is saying, "I have recalled the grades of hundreds of students, mentally computed averages, and found the male average score to be higher." The utter absurdity of such a statement shows how untrustworthy are all conclusions based on recalling unrecorded data. Scientific observation is objective. This means that insofar as is humanly possible, observation is unaffected by the observer's own belief, preferences, wishes, or values. In other words, objectivity means the ability to see and accept facts as they are, not as one might wish them to be. It is fairly easy to be objective when observing something about which we have no preferences or values. It is fairly easy to study objectively the mating practices of a fruit fly, but less easy to view the mating practices of the human being with objective detachment. Scientific observations are made by trained observers. A million people watch the sun and the moon sweep across the sky, but most sophisticated observers know that is not exactly what happens. Untrained observers do not know what to look for and how to interpret it. They do not know the pitfalls which lead to inaccurate observation, nor are they fully aware of tricks their own limitations and biases may play on them. Startling reports of weird phenomena generally come from uneducated, unsophisticated persons and are discounted by the experts. Scientific observations are made under controlled conditions. Laboratories are popular with scientists because they are handy places to control variables such as heat, light, air, pressure, time intervals, or whatever is important. A variable is anything which varies from case to case. For example, people vary in height, weight, age, sex, race, religion, education, occupation, income, health, behavior, characteristics, and many other things. We have a scientific experiment when we control all important variables except one and see what happens when that one is varied. Unless all variables except one have been controlled, we cannot be sure which variable has produced the results. In these several respects, then, scientific observation differs from looking at things. We spend our lives looking at things, and this activity brings us much information, many impressions, and numerous conclusions. But these conclusions are clouded by accidents of coincidence, by selecting memory, and by personal bias. Therefore, before accepting any generalization as true, the critical observer wants to know what it is based upon. Is a conclusion based upon systematically collected body of scientific evidence, or is it an offhand reaction to hazard observation? So it was for today. Our next lecture will be what is the scientific method of investigation. Please subscribe for more videos and latest updates, and do not forget to like us on Facebook. Thank you very much.